Kia ora, Year 12. This is a question for Harry Z, and this is a rates of change question. So if you're watching this and you're in 13 MCA, this is much easier than the chain rule stuff we've done this year, so you probably don't need to watch this video. But if you're in 12 MCA, it's a nice example of how we can use the chain rule to solve rates of change questions. So we're given a cardboard box or something, some kind of cuboid, and it's got the dimensions shown in the diagram. So the first thing we need to do is to show a link between the surface area and the volume. Okay, so the surface area, the volume is going to be easy, right? It's going to be length times width times height. And the surface area is going to be 2 lots of this side, this pair, 2 lots of that one, and 2 lots of this one. So we're going to get an expression in terms of x for v, and then an expression in terms of x in terms for s. So v is equal to length times width times height, so that's going to be 2x times 4x times x, which is 8x cubed, and then s is going to be 2 lots of 2x squared plus 8x squared. Let's see, 2x squared plus 8x squared, so that's that one. 4x, let's see, that's the 8x squared one, and then the last one is the 4x squared one. So when we add that up, what are we going to get? We're going to get 10, 14, 28x squared. So what we have to do now is to show that s is equal to 7v to the power of 2/3. So let's just start by saying 7v to the power of 2/3 is equal to 7 times 8x cubed to the power of 2/3. Right, so that's equal to, let's look at the 8 first. So the cube root of 8 is 2. 2 squared is 4, so it's 7 times 4. And then this bit works out to be x squared. So we get 28x squared, which is equal to s as required. So that's the first part of the question done. Now let's translate this next part into some numbers and see what we get. So the first thing we see is that when the volume of the cuboid is 1000 centimeters cubed, the surface area is increasing at 2 centimeters squared per second. We have to find the rate of increase of the volume at this instance. Now the worst thing you can do with questions like this is to get hung up on the volume being 1000 centimeters cubed too early. First, what we want to do is say, what are we trying to find? Well, we want to find dv by dt when v is equal to 1000. The last thing we're going to use in the question is that information. And we know that when that's the case, the surface area is increasing at this rate. So that means that ds by dt equals 2 when this is happening. So let's get our expression for dv by dt. So dv by dt is going to equal dv by ds times ds by dt. And we know from before that s is equal to 7v to the power of 2/3. Differentiating that gives me ds by dv, which is not quite what we want, but it's easy to get it from here. So it's going to be 14 over 3 times v to the negative 1/3, which is the same as 14 over 3v to the power of 1/3. Now we need dv by ds. So it's going to be the reciprocal of ds by dv, 3v to the 1/3 over 14. So let's start substituting some stuff in. dv by dt will equal 3v to the 1/3 over 14 times ds by dt. Now we're ready to substitute in. So when v is equal to 1000, ds by dt is equal to 2. So dv by dt at s equals 2 will equal 3 times the cube root of this, which is 10, over 14, times 2, which equals 30 divided by 7 cubic centimetres per second. Okay, now I haven't bothered to chuck that into my calculator and see what it works out to be, but it will be 4.28 something, or maybe 4.29. Okay, so we'd want to get that to a 3 significant figures answer. So there you go, Harry. I hope that helps. The chain rule is your friend all the way through calculus. And this property that we used here, where we find what we can find easily and then flip it upside down, is a really nice one. So the way that these can be manipulated comes in handy in quite a lot of problems. I'm not going to go through why that works in this video, okay, because it would take too long, but it does.